Hello everyone, Namaskar. I hope you all are doing great. Today in this particular video we will be talking about engine bleed architecture. This very important architecture of pneumatic system. So let's start. Let me tell you, meanwhile, while explaining this whole architecture, I will be asking you few questions. These questions are from Smart Cockpit or some other question banks. After completing this video, you will be able to answer all the related questions related to this particular engine bleed architecture, right? So let's start. Disclaimer: I do not own any of the image and content used in this course. All of it is just a reproduction of Airbus manuals, images from the Google or the CBTs, just to serve the purpose of easy understanding of the system. I request, if you find any incorrect or inappropriate explanation of any topic, please let me know in comments, or you can send me direct message. I will definitely correct myself, right? So let's start with the architecture. So what we are studying today is we are studying particularly engine bleed system, and in this engine bleed system there will be architecture. So we will be covering the whole engine bleed system of pneumatic. I have made so many other videos on the leak detection, BMC failure, and even a complete video of whole pneumatic system explained from the FCOM. You can go and check out all the videos. They will be definitely helpful for you. So let's start with the architecture. Guys, can you tell how many engines do your aircraft has? Definitely there are two engines, and each engine can produce bleed air, obviously, right? So each engine has the engine bleed system, right? And each system is designed to select the compressor stages to use as a source of air. Each system is designed to regulate the bleed air temperature, and each system is designed to regulate the bleed air pressure. So each engine has a engine bleed air system, right? Each engine can produce bleed, and it can supply bleed to the different systems. Now this each system is designed to select the compressor stages, is designed to regulate the bleed air temperature, and it is designed to regulate the bleed air pressure. I will discuss all 3 points one by one, and while explaining all these 3 points, we will be covering the whole this architecture. We will be talking about all the valves, and we will talk about this check valve, how the pressure, how the bleed air is taken from the which stages, how the pre-cooler works, what is overpressure valve. Then we will see how this ground air supply and APU are connected with the cross bleed duct, right? So first of all, let me tell you how this engine is designed to select the compressor stages. So generally bleed air is taken from the intermediate stages of the high pressure compressor to minimize the fuel penalty generally. So this is how your engine looks like, right? This is low pressure compressor, this is high pressure compressor, and this is high pressure turbine, and this is low pressure turbine, right? So your bleed air is taken from the high pressure compressor, and in particular high pressure compressor, generally air is taken from the intermediate stages of high pressure compressor to minimize the fuel penalty, right? But if pressure is not sufficient enough, then bleed can be taken from the high pressure stages of high pressure compressor. So there are different stator rotors depending on the engine, right? In this particular engine we are talking about, there are 9 stator rotor stages. So intermediate stages, now imagine yourself maybe around 4, 5, 6 will be intermediate if I'm not wrong. I know I'm not telling you the exact number of stages, but this is rough idea, right? Perfect. So when bleed air is taken from the intermediate stages, it is supplied to the bleed valve further. Now, if this pressure and temperature is not sufficient enough, then HP valve opens. So your bleed valve maintains pressure of 45 plus minus 5 psi, and over here the pressure will be somewhere around 36 plus minus 4 psi. So if this pressure is not maintained, then this HP valve opens automatically and it provides the bleed air to the bleed valve. It makes sense. Now when this HP valve opens, this IEP valve also remain open. It does not close. So bleed is taken and supplied to the bleed valve, and then further it goes to the overpressure valve, and then via pre-cooler it goes to the different systems. For wing anti-ice, for AC packs, for forward and aft cargo heating, hydraulic reservoir, water tank pressurization, right? That's perfect. Now I will tell you what is this, and then we will talk about the bleed valve in detail. So this is a symbol of check valve. So this check valve is to this pressure check valve is downstream of IP port. It closes to prevent air from the HP stages from being circulated to IP stages. So what does this FCOM says is, you will be having high pressure over here when HP is supplying the bleed. So there are chances that HP, high pressure air, will go to the intermediate stages. So this IP check valve prevents this reverse flow, right? So that this engine does not damage from here. And this check valve is used at so many places. You can see over here, right here. So you will find some questions also on this check valve. The this question is like, a check valve near the cross bleed duct protects the APU when bleed air comes from the another sources. They are talking about this check valve. So this check valve near the APU bleed valve prevents and protects the APU when bleed air comes from the engines, right? Or the HP ground source. Right, just a second, let me erase it. Now you have a fair idea of the whole schematic diagram. Now you know that air is taken from the intermediate stages generally, and now you know what are the intermediate stages of high pressure compressor, and you know what are the high pressure stages of high pressure compressor. Now you know that HP valve opens when the pressure and temperature is not sufficient enough, right? And when this HP valve opens, the IP valve also remains open, but this IP check valve prevents air from going from here to here. Makes sense. Now maybe 3 or 4 questions has already covered. Now comes this bleed valve, very important valve of this whole pneumatic system. This bleed valve is also called pressure regulating valve. This is also called shut off valve, right? Now guys, tell me why this valve is called pressure regulating valve. Do you have any idea? And why this valve is also called shut off valve? uh, Try to answer it, and when you will be thinking about it, you will come to know that this bleed valve makes sure that the delivery pressure is 45 plus minus 5 psi. So it regulates the bleed pressure. The bleed which is leaving bleed valve, its delivery pressure will be somewhere around 45 plus minus 5 psi. That's why this valve is called pressure regulating valve, and that's why this particular statement over here is written. Each system is designed to regulate the bleed air pressure because of this pressure regulating valve, right? Right? We have discussed the first point. It can select the compressor stage to use as a source of air. We have discussed it in detail. We are talking about this regulation of bleed air pressure, how this system regulates the bleed air pressure. So it regulates the bleed air pressure with the help of bleed valve. Right. Now when this bleed valve has regulated the pressure at around 45 plus minus 5 psi, then further this bleed goes down the stream. So guys, please don't be confused in downstream and upstream concept of this whole pneumatic system. Even I used to get confused when I was preparing. So let me make it clear for you. Assume yourself at bleed valve. Assume yourself over here, right? Now bleed is moving like this, right? So this is down the stream and this is upstream with respect to bleed valve. Now if you change your position, now with respect to HP valve, bleed is moving like this. So with respect to HP valve, this is downstream and this area is upstream. So this upstream and downstream depends on the position and depends on the valve you are putting in center, right? So bleed valve regulates the pressure, makes sense. Now further bleed moves down the stream and it goes to the overpressure valve over here. Now this overpressure valve makes sure that the pressure is not more than 75 psi. If the pressure of the bleed valve is more than 75 psi, it will not be more than 75 psi. Calm, relax, because bleed valve is here. Bleed valve will make sure it is 45 plus minus 5 psi. But if in case, what if pressure is 75 or more than 75, then this bleed valve will be like, oh, I am here, no need to worry. I will close and will not move. I will not the bleed air move further. It will close and bleed air will not damage the other systems like wing anti-ice, like packs, cargo heating. It will not destroy anything. This overpressure valve will close. Perfect. It makes sense. Now down the stream you will find a pre-cooler. Now the third and very important point of this engine bleed system, that it can regulate the bleed air temperature. This beautiful system can regulate the bleed air temperature. So whatever amount of bleed is going, this system can regulate the temperature of this bleed. How? With the help of pre-cooler. Now how pre-cooler cools down the bleed? So there will be a temperature of, I think, if I'm not sure, please don't take my these numbers to your serious consideration. I am not an engineer, but I have read it somewhere that pressure or temperature is somewhere around 300 or I think 400 degrees Celsius. So this pre-cooler cools it down to 200 degrees Celsius. This is correct number. So this pre-cooler makes sure that the bleed which is leaving the pre-cooler should have a temperature of 200 degrees Celsius. This is written in your book, in your FCOM. Forget this number. Remember 200 degrees Celsius only. So when the bleed is leaving the pre-cooler, its temperature will be 200 degrees Celsius or less, so that it do not destroy the further components and further systems. And what will be the pressure of the bleed? Pressure will be somewhere because bleed valve was regulating it to 45 plus minus 5 psi, right? So this will be your temperature, pressure. Perfect, and it makes sense. Now I have covered all the valves in between. This is engine 1 starter. Here the air goes to the start, air goes to start the engine. Perfect. Then bleed goes to different system for wing anti-ice, for the AC packs. You will be studying about this pack in the air conditioning chapter, right? And here to the cross bleed duct. This is cross bleed duct. So the cross bleed duct is the place where all three high pressure sources are connected with. How many sources are there? There are three sources: ground air supply, APU, and the engines, right? This is also one of the question. So what are the pneumatic system which are connected with the high pressure sources, or what are the system high pressure sources gives bleed air to? So these are the systems air is given to, bleed air is given to, right? Question number XYZ covered. Okay, few more things about the pre-cooler. Okay, don't be confused in the statements. Engine bleed air temperature is controlled by the pre-cooler that uses fan air. So basically, how this pre-cooler cools down the air? So air is taken, a cool air is taken from the fan section of the engine. Here the air is not pressurized because it is at the fan section, it has not compressed yet. So this is very cooled air. So this cooled air is taken from the fan section and thrown over the pre-cooler. This is, I think it's a muffler type heat exchanger. So it cools down this muffler and the bleed air goes from this pre-cooler. So it cools down the temperature of bleed air. This is how it works. Perfect. Here is this fan air valve, the spring loaded fan air valve, right? It closes if the engine is switched off or engine is not running. This fan air valve closes. If engine is running, this will open and then air will be supplied to pre-cooler, right? There is one more statement which says air bleed from the engine is cooled in the heat exchanger by cooling air bleed from the fan section. I hope you are not finding any difficulty in these statements. Perfect. Now I have told you about this overpressure valve, right? I told you that it will not allow bleed to go if its pressure is more than 75 psi. This bleed overpressure valve will close. So if pressure regulation fails, the overpressure valve closes when the pressure goes over 75 psi. Right? Makes sense? Now, very important, the closure conditions of bleed valve. A lot of guys must be facing difficulty that what are the closure conditions of this bleed valve, and what is this pneumatic closure, and what is this electrical closure, and you will find so many questions on this closure conditions. So I will try to make it easy for you. And where these closure conditions are written, let me show you first. Then either you can pause the video and read it, number one. If you want me to explain it, then I will just try to draw for you. So this bleed valve can be closed either pneumatically with the help of air, or this bleed valve can be closed with the help of BMC, electrically, I should say electrically. So this bleed valve either can be closed pneumatically or electrically. So what are the conditions when this bleed valve will close pneumatically? So whenever there is a reverse airflow sensed, this bleed valve will close. And it makes sense. Generally, bleed air should go in this direction, right? But what if the reverse airflow occurs? Suppose APU was running, right, and bleed air is going like this. It will damage your engine. It will damage the intermediate or HP stages of your engines, and engines are very expensive, trust me. Very expensive. So this bleed valve will close automatically, right? And it should be. If it is not closing automatically, then what is the use of this automation? And this is why this Airbus is known of its because of its automation, right? And the second reason, so the first reason is when the reverse flow occurs, and the second reason is whenever the pressure of minus 8 psi or less than 8 psi, I should say, less than 8 psi is sensed upstream. So this is upstream and this is downstream of the bleed valve. So whenever pressure of 8 psi is sensed, less than 8 psi is sensed at the upstream, so then this bleed valve closes. So if there is less pressure over here and there is high pressure over here, so I should say low pressure over here and high pressure over here, so air will move like this, right? High to low, air to go, air will move like this. So reverse flow will occur indirectly. Both statements are same. So this is the pneumatic closure. I have made a notes for you. This is, yeah, these are the pneumatic closure conditions. These two conditions are for pneumatic closure, number 1 and number 2. Now we will discussing the electrical closure conditions, and after that we will discuss the questions on this closure conditions. Now guys, let me tell you, your bleed monitoring computer BMC will automatically close your bleed valve. In what conditions? I will tell you. So guys, tell me, if APU is being on, right? And APU is supplying the bleed air. So tell me, APU has priority or engines has priority? Obviously APU has priority. APU bleed has priority over engine bleed. So your APU will be supplying. So at that moment, does or should your bleed valve remain open? If in that case your bleed valve remains open, that will damage it. If the bleed APU bleed is being on, APU bleed is being on, if the bleed valve is open, then it will damage it. So this should not be open, it should be closed. So chill, BMC is here for you. BMC will automatically close this bleed valve, respective bleed valve. BMC 1 will do it and BMC 2 will close this engine number 2 bleed valve, right? Relax. So this is the electrical closure conditions I am telling you. Now the second, if engine has been shut down. When engine has shut down, is there any need to this bleed valve remain open? If engine has been shut down, this engine is not running, is there any need of this bleed valve to remain open? Obviously no. And BMC knows this, so BMC will close it. Make sense? Right. Third, if leak has been detected, guys, if there is I'm taking an example of left hand side. If leak has been detected towards the left side and left engine was running, what do you think? There should be okay, I will show you a statement, then it will make it more clear for you. Just a second. So you will find a question which says, if a BMC detects a bleed leak, all valves that could supply pneumatic air to that area of bleed leak will close automatically, right? And this should happen if a leak has been detected. So all the valves which can supply the pneumatic air to that area should be closed automatically. So BMC will close all the related valves. So if the bleed leak has been detected towards the left side, so left hand side where I was, so left hand side bleed valve will close automatically with the help of BMC, right? So I'm just discussing all the points which are written over here. If there is over temperature sensed, over pressure sensed, and open starter valve is sensed, leak is sensed, engine shutdown is sensed, APU bleed is being on, in all these cases your BMC will close the bleed valve automatically, electrically, right? Now it makes sense. Now you know both the pneumatic closure conditions. Now you know all the electrical closure conditions with the help of BMCs. Now there are two more conditions. I should say these electrical closure, manual electrical closure. So how you can manually close this bleed valve? What do you think? Do you have any access to close these bleed valves? If you have done your type rating or you have studied this chapter, you must be having some idea that this push button, engine 1 bleed push button on the air conditioning panel overhead, has direct access for this bleed valve. If you have pressed this push button to off, this bleed valve will be closed, right? So one more point over here, how you can close this bleed valve with the help of this push button. Another one is, if you have pressed this fire push button handle on the fire panel for the engine 1, so it will also close the bleed valve, right? These are two manual electrical closure of this bleed valve. So what we were discussing till now was all the conditions where this bleed valve can be closed either pneumatically or electrically, automatically, or manually. So we have discussed all the things about the closure of this bleed valve. Now I think now you will not be having any difficulty in this closure of this bleed valve. You can go and take a screenshot of it if you want, right? Perfect. Now the only thing which is remaining is the HP valve closure conditions, and it will take only 1 minute. That's why this is how I have designed this video, so that I will tell you about the bleed valve closer first, and then I will tell you about the HP bleed valve closer. It will take hardly 1 or 2 minutes, but before that, answer two questions. Like, you tell me, is it correct or not? The pressure regulating and shut off valve will close. So basically they are talking about bleed valve. The bleed valve will close automatically if upstream pressure is low and reverse airflow occurs. Guys, obviously these were the pneumatic closure conditions of this bleed valve. Perfect. Second, with the loss of pneumatic system pressure, the engine bleed valve will assume the closed position. So guys, they are talking about the engine is not running. When the loss of pneumatic system pressure, engine is not running, the bleed valve will assume the closed position. The bleed valve will close, right? Guys, trust me, if you will solve the questions of pneumatics after watching this video, or not particular this video, if you have watched this whole pneumatic system explanation from the FCOM, which is I think 1.5 hour long video, after that video you will not be facing any difficulty in solving the questions except 4 or 5 questions of smart cockpit, because those questions are from air conditioning and pressurization. But other than those, you will not be facing any difficulty. If you do, please come back and watch this video, or comment below or send me direct message. I will definitely try to answer all of your questions. Right, so now comes the last HP valve closure conditions. So guys, there are also pneumatic closure and electric closure. So let me tell you, both pneumatic and electric closures are almost similar to the bleed valve. Electric closure is same as the bleed valve closure conditions. So HP valve will also either can be pneumatically closed or electrically closed. So guys, whenever bleed valve is electrically closed, this HP valve will also electrically close. So all the conditions of electric closure is similar for the HP valve also. Now comes the pneumatic closure conditions. So whenever there is low upstream pressure, so for HP valve, okay, now comes the test time. So guys, tell me, if you put yourself at HP valve, so what is upstream and what is downstream? Correct me if I'm wrong. This is downstream and this is upstream, because the air will be moving like this. So whenever the low upstream pressure is sensed, here low pressure is sensed and here high pressure is sensed, In this case, HP bleed valve, HP valve will pneumatically close automatically, right? Right. Second, whenever there is excessive upstream pressure is sensed, here in this area, excessive upstream pressure, I don't know the exact number how much excessive pressure is sensed, but whenever excessive upstream pressure is sensed, then also this HP valve closes so that it does not damage the, I think, bleed valve and further components. If it is excessive, then this bleed this valve, HP valve, should be closed, right? So these are the two conditions of HP valve closure, right? So here these are, you can take a screenshot of it. So pneumatic closure, two conditions, and electric closure is similar to the bleed valve closure conditions. Right, now I have covered all the things of this schematic diagram. I have told you about the check valve, I have told you about the HP sources. Yeah, this is called cross bleed duct. This is cross bleed valve. I will talk about the cross bleed valve in another video uh, of cross bleed section. Yeah, if you wants to know more about the APU bleed valve, how the BMC failure works, like how your system works in case of BMC failure, how leak is detected and everything, then you can go and check out my other videos in which I have discussed these topics in detail. uh, I have already made those videos, right? So I hope you like this video. Hope to see you soon somewhere, right? Bye. See you.